So this section is going to be on relations and functions. So we're going to talk about how something can be a function, a relation can be a function, and how a relation cannot be a function. So in this first part, we have a function. In order for a relation to be a function, each domain, so each x value, should only be paired with one range, so y value. So each input will only have one output. So you can't have double of the same number for inputs, but you could have many of the same outputs, and we'll show you in further examples. But only like one input should be with one output in that case. Now, for something to not be a function is when a domain is paired with more than one range, so your y. So an x is paired with more than one range. That would consider it not being a function. So for example, this is a function because each input is paired with directly one output. So there is no multiple x values that are the same. So if you were to write these out, you would see that this is 1, 5, 2, 10, 3, 15, and 4, 20. Now, if you notice that there is one domain per output, so like the domains cannot repeat in this case. So if you see that this is going up by 5, up by 5, up by 5, up by 5, all the way, and then up by 1, up by 1, up by 1. So this function would be y equals, it's always our y over x, so 5x. So you would write that as a function, f of x is equal to 5x. So that's something that you'll start seeing, that this is actually a function. So you'll see it in the function notation. Now, an example of these are called mapping diagrams, and the reason that these don't work is that I wrote out the pairs. So you have 2, the input of 2 is paired with 10, and the input of 2 is paired with 20. Because 2 is paired with 2 different outputs, this would not be a function. So you cannot have an input paired with 2 different outputs. Now, if this was just like 2 and 10 and 4 and 20 and 6 and 30 and 8 and 40, then it would work. But in this case, this would not be a function. So if you notice, so I'll circle that you have 2 of the same domains. So in this case, if you were to write out your domains, you would have 2, 2, 4, 6, 8, and because you have 2 of these, which you can't, that would be why it is not a function. Doesn't matter if the ranges repeat, so in this case the range is repeated, that's okay. It cannot have the same input, can't have the same, there are different outputs. So in this next one, this one is a function because of the fact that each input has one output. It doesn't matter if all of these are the same because there's one domain of 3 that has the output of 10. There's one input of 4 that has the output of 10. So it doesn't, I'm going to write this down. This is a special thing to remember, is that the range can repeat. So they can have many of the same numbers. Now this is another version of a table, and if you notice, you have 4, is the input, and its output is 10. 4, the output is 11, so this would not be a function because of the fact that there's 2 inputs that have 2 of the same inputs that have different outputs. So that is why that would not work. So because you have 2, so if you were to write out the domains, you would notice that all the domains would be 4, 4, 8, and 12. And because you can't have an input being the same number, that's why this would not be a function. If you did the range, you would notice that there is different ranges, but that's not going to matter. it only matters. You're looking really at the domain for all of these. Now, another example would be that if you have a graph, you can determine if it is a function by a vertical line test. And if you notice, you're only going through an input is x values. So we've been looking at all of the x values throughout this entire lesson. And if you think about it, x values, all the x values are like when you were to graph a linear equation, it was a vertical line. So you're using, because you want to see if it works and you don't want the line to go through 2 points. If it goes through 2 points, then it is not a function. So in this first one, if I were to draw a vertical line anywhere on this graph, so if I were to draw a vertical line, it would mean that this is a function because of the fact that it only passes through each point once, or each x value once. So in this case, I could draw, let's say I drew a vertical line down this point. This would be a function in the fact that it only went through this point one time. Now, if there was another point down here, it would not be a function because it went through that point twice. So if you notice, if you were to write out your domain or range, the domain would be all of the x values, and it wouldn't go through more than 1 point. So in this case, it would be a function. Now in this one, because of the fact if you were to draw a vertical line anywhere on this graph, now if you drew a vertical line here, it wouldn't go through the line twice. But if I were to draw anywhere else, this vertical line, notice that it goes through 2 of the points, which means that there would be 2 domains that have the same x value. So in this case, there would be 2 domains that have the x value of 3. So this would not work. So if it can go through, now like if I were to draw the vertical line here, it would only go through 1 time. If I were to draw it through here, it'd only go through 1 time. If I were to draw it through here, it'd go through twice. Here, it go through twice. So this graph is not a function. This one would be a function because it only goes through once.